Let's continue with properties of integer exponents. We focus on scientific notation. Scientific notation is written as a times 10 to the power of n. A is a number whose absolute value is between 1 and 10, and n is an integer. Scientific notation is used when A is a very large or very small number. For example, when we describe the distance between Earth and Venus, it's convenient to use scientific notation. And when the number is very tiny, like the width of a water molecule, it's convenient to use scientific notation. Let's go through some examples. Writing standard notation. Writing standard notation means without 10 to the n power. So what we will do will be move the dot. 6.629 is given. Then this power is 5. So 1, 2, 3, 4, 5. So we have to write 0 and 0. So the final answer will become 662,900. Next example has a negative power. In that case, we have to move the dot to the left. Let's copy the original problem, the original decimal point, 8.189, and then we have to move the dot 6 times. And then write the dot here and put 0 in the remaining spot. So the final answer will become 0.000008189. The following example is about writing 260,000 in scientific notation. What you have to recall is when we say scientific notation, we multiply two numbers, A, whose absolute value stay between 1 and 10 to the n power when n is an integer. When we write 260,000, what we have to take in this case will be the first part, which doesn't have the 0. And then what we know is A must stay between 1 and 10. So from here, we will take 2.6. And then what we know is there are 4 zeros. 1, 2, 3, 4. So what you have to count will be 1, 2, 3, 4, 5. So it moved 5 times. So that can be written as 2.6 times 10 to the 5 power. So this is the final answer. This time we want to calculate the scientific notation, multiplication of scientific notations. What we have to do will be, we will calculate this 10 to something part together and number part together. So let's combine those. So 4 times 2.2 times 10 times 6, 10 to the 6th power times 10 to the 3rd power. Then this one will be 8.8 times 10 to the, what should we do? We have to add each exponent. Then that'll be 10 to the 9th power. So this is the final answer. The next example is 5 times 10 to the 7th power over 2 times 10 squared. As we did, we will get a number together and 10 to the power of something. So we will calculate like this. So we have 5 over 2 times 10 to the 7th power over 10 squared. The first number is obviously 2.5 times 10 to the 7th power minus 2 equals 2.5 times 10 to the 5th power. This is the last answer. What property did I use? 1 over a to the n power is a to the negative n power. So when you combine the numerator and denominator together, you have to subtract the power in the denominator. What you have to be careful about is, in this case, we are multiplying the numbers on the numerator and denominator. So we can separate in this way. Let's suppose that we have 5 plus 10 to the 7th power over 2 plus 10 squared. Then you cannot combine like this because those are added. And 10 to the 7th power and 10 squared in the denominator cannot be simplified by just combining those together. Let's review what we did last time with the basic property of exponents. What you have to remember is when u is written like this, without power, that just means this is u to the 1 power. 1 is hidden. It is not 0. So when we add a power to simplify, we have to add 4. No number appears here, but we have to put 1 minus 9. So that's u to the negative 4th power. In the problem, we have to use positive exponents. So that is u to the 4th power. 1 over u to the 4th power, because I said 1 over u to the nth power is u to the negative nth power. In the next problem, we see many characters and numbers together. What we have to do is we have to combine the number together and character together. So it becomes 4 times 3 times 6 times the u variable. So u to the negative 6 power times u cubed times, we consider the base number x, then x to the negative 7th power times x to the 7th power. Lastly, we have y, base number y, then y to the negative 5th power times y. When you multiply all of these, we will get 72. And then this one will become negative u to the negative 6 plus 3. And then x to the negative 7 plus 7. And y to the negative 5 plus 1. Remember, y is y to the 1 power. So we have 72 times u to the negative 3 power, x to the 0 power, y to the negative 4 power. What do we know about the number is a to the 0 power is always 1. What does that mean? This one will vanish. And what we know is when we have a negative power, we have to put that in the denominator. So denominator will become u cubed times y to the fourth power. The numerator is 72 because there is no negative power for the number 72. The other important fact I used here is a times b to the minus 1 is a times 1 over b, and that can be written as a over b. Why is that? A is indeed a over 1. The next problem is x to the fifth power minus 3. Then that'll be x to the 5 plus 3, which is x to the eighth power. What property did I use? I, of course, used this property more directly. A to the power of m over a to the power of n is a to the power of m minus power of n. To solve the next problem, what we want to do is we want to separate according to the base number. So we will rewrite as a to the fourth power over a to the ninth power times b to the negative ninth power over b squared times c to the negative eighth power over c cubed. So that is a to the fourth power minus 5 times b to the negative ninth power minus 2 times c to the negative eighth power minus 3. So that'll be a to the 4 plus 5 times b to the negative 11 times c to the negative 11. What is this? This one is a to the ninth power times 1 over b to the 11th power times 1 over c to the 11th power. I said this can be regarded as a to the ninth power over 1. So we multiply the numerators together and denominators together to get a to the ninth power over b to the 11th power times c to the 11th power. In the next problem, we have negative power applied to the fraction. This is a negative power. What may be a little bit more convenient will be reposition the numerator and denominator by switching, like 4w squared over x squared, and write it as a positive power. And then what we have to do is we distribute this exponent to each component. So that becomes 4 squared w squared squared over x squared squared. So that is 16 times w to the fourth power over x to the fourth power. The next problem is also a similar pattern. We have a negative power, so we will reposition the numerator and denominator by flipping. So we have 2 times z to the negative 6 power over z to the negative 3 power, and then remove negative sign here. What's important here, and maybe confusing, is when you reposition, you don't remove minus power here, because repositioning is solely related to this minus sign in the exponent. And then we will distribute the power. That is 2 squared times z to the negative 6 times 2 over z to the negative 3 times 2, which is 4 times z to the negative 12 over z to the negative 6 power. So we can combine z to the something power. So z to the negative 12 minus 6. So that is 4 times z to the negative 12 plus 6, which is 4 times z to the negative 6 power. So that can be written as 4 over 1 times 1 over z to the 6th power, which is 4 over z to the 6th power. Other way to solve the problem is related to your observation. Different from the previous problem that contains 2 different variables, x and w. In this problem, we have the base character the same. Those are 2, z. Therefore, we can simplify the fraction first. Let's separate like 1 over 2 times z to the negative 3 minus 6, and then minus 2 power. Here, 1 over 2 can be written as 2 to the negative 1 power. Therefore, we can rewrite it as 2 to the negative 1 power times z to the negative 3 plus 6 power to the negative 2 power. So as we did we have to distribute this power to the first and second power. Let's rewrite it again. Then z to the negative 1 power, 2 to the negative 1 power times z to the third to the power of negative 2. So we distribute the power to the first and second. Then that is 2 to the negative 1 times negative 2 times z cubed negative 2. So that's 2 squared times z to the negative 6 power. So 4 times 1 over z to the 6th power. 4 is 4 over 1. So that's 4 over z to the 6th power. So we are getting the same answer. Whichever you like, you can use the method you like. In the next question, we have x to the negative 3 power times z to the 5th power times 3xy squared y cubed over z to the negative 1 power to the negative 2 power. What we want to do first will be rewriting this like this. X to the negative 3 power is 1 over x cubed times z to the 5th power is z to the 5th power over 1 times what we want to do first is this is a negative power. So we want to flip the positions. Then it becomes z to the negative 1 over 3xy cubed. After we flip, we can drop the minus sign on the power. And then we want to distribute this to each factor. Then that'll become z to the 5th power over x cubed times z to the negative 2 power over 3 squared times x squared times y cubed times 2. Usually we write the number first, so let's write the number first. 3 squared is 9, so let me write down 9 here. And then the same characters together, x cubed times x squared times we have y to the 6th power, and then z to the, we have 2z. So z to the 5th power minus 2. So that's z cubed over 9 times x cubed plus 2 times y to the 6th power. So that's z cubed over 9 times x to the 5th power times y to the 6th power. The next question is 54 times u to the fifth power v squared over 6uv. Let's separate according to the pattern. Number together 54 over 6 times u to the fifth power over u times v squared over v. 54 is 6 times 9. And u to the u and v can be regarded as u to the power of 1 and v to the power of 1. And the same number in the numerator and denominator will cancel each other. So the first will become 9. The second one will be 5 minus 1 times v squared minus 1. So that is 9 times u to the fourth power, v to the 1 power, which is 9 u to the fourth power v.